चलता पाहिजे वंदन.
एक ओंकार सतनाम करता पुरख निर्भौ निर्वैर अकाल मूरत अजूनी.
Sir, we are on a count of 4, 3, 2, 1. We are live now.
Copy.
Copy, Somalo, thank you.
Take it on and confirm me, sir, please.
Thank you. Wait for a while.
We know that as we grow, the hurdles will be more. Each time we are washed away, we bounce back to the shore. We know we lead the way, keeping odds at bay. See the sunrise tomorrow, inspire the world to follow. Our lives is really tomorrow. I'm sleeping now.
हमने तो पेन दा पेन पेन.
Hello.
You're the ones shining bright, even in the darkest night. Igniting minds, empowering lives, we win us tomorrow bright. We have what it takes to win and achieve what we dream. We can calm the stormy sea, our courage echoes eternally. Our life is really our tomorrow, I'm leaving here tomorrow.
Sound tested. Copy. Somale. Copy confirm.
Okay, sir, copy it.
Copy confirm. Facebook.
Okay, thank you, sir.
স্যার একটু পরে জয়েন করে যান স্যার. হ্যাঁ হ্যাঁ.
ঠিক আছে. Ladies and gentlemen, please mute yourself. Everyone, please mute yourself. Thank you.
एक ओंकार सतनाम करता पुरख.
Sakshat, this is the last loop. Copy it.
Yes, sir. We will continue. We will continue. Soikut sir,
Yeah,
we will continue the loop.
it will continue till the end.
Yeah.
Okay, copy. Somala, copy.
We know that as we grow, the hurdles will be more. Each time we are washed away, we bounce back to the shore. We know we lead the way, keeping odds at bay. See the sunrise tomorrow and fly the world to follow. From sea to
Maji sir, video interrupted, copy.
Yeah.
Somala, check Facebook, copy.
shining bright, even in the darkest night. Igniting minds,
Checking, sir, checking.
empowering life within us tomorrow bright. We have what it takes to win and achieve what we dream. We can calm a stormy sea. Our courage grows eternally. Our life we are tomorrow.
Asu sir, good morning.
Good
Welcome,
morning.
sir.
Good morning.
Welcome, sir.
Thank you. Thank you. I don't know whether you can hear or not.
Oh, okay, sir. You are audible, sir.
Yeah, we can hear.
It's all right.
Copy Facebook. Check and confirm.
Dr. Mighty, please continue. Let the dignitaries come and join our session.
Yeah, it's
Once more.
copied. It's copied.
Facebook confirm, sir.
It will continue. No issue.
More minutes to continue.
Yeah, 10 more minutes.
Somala, Facebook confirm, copy.
Confirm, sir. It's live.
Thank you.
আমি কমেন্ট করলে তোকে দেখাবে ভাই
Audience, please mute yourself. Audience, please mute yourself.
Machi sir, mute all, then unmute me and Somalia. Copy.
It's very difficult, sir. You can unmute. I'm muting all. Komalla and Soikut, sir, I cannot find.
Sir, I am unmute. Sir,
Yeah. Copied Soikut, sir. Somalla copy.
copy, sir.
Yeah. You search Soikut, sir, and we have to unmute him. Soikut sir, can you hear me?
Okay, it's on live.
Soikut sir, can you hear me?
Because sir, theme music is not coming. Because sir,
Soikut sir, are you here?
Soikat sir, I think Soikat sir is not
Yeah, he's not there.
there.
Sak sir,
Yes, sir.
yeah, can we play this? No.
No, we can't play this. Request to
We
control this.
Yes, sir.
we can play, sir. I think. No, we can't play. We can't play.
We can't play. Just
Saksar, you can hear me? Saksar?
Yes, sir.
Okay.
Yes, sir.
Okay.
sir, one thing you can do, if you have the video, you can play. You can share screen and you can play it if you want.
Yes, but the video option is not here right now. For that, I need to make myself host.
No, video
I don't.
option will not be there because only option is
Only
there
the
is screen sharing.
sound. Yes, only the sound I'll be able to share, not the video part.
Okay.
For
Okay,
that,
then
I need to
wait
make
for
myself host. I need to
wait
be
for
host.
some time. Okay. Yeah, yeah, okay. Uh, sir, sound is not coming.
Soikat sir,
So Somallo copy, Somallo.
Yes, copy, sir.
Yeah, we have stopped the video. Soikat sir is playing once again.
Okay. Now it is coming, sir. You have to unmute yourself to so that we can listen you.
okay, okay, okay.
I think you miss one option, sir. Share computer sound. There is a option for screen sharing.
Hello.
So you got, sir.
Yes.
Somalia, ensure Facebook open.
Facebook is in live perfectly. 30 people are watching currently.
Hello, hello.
Somalia, copy.
Copy, sir. All okay, sir.
Ladies and gentlemen, please mute yourself, please. Professor Maji, ensure YouTube, please.
Yeah, it's on YouTube. It's on YouTube. I've got a delay, but people are watching. 42
Okay.
watching now. 42 watching now.
Okay, copy. Sakshar on board, copy.
Yes, sir.
Thank you.
Sir, can we start now?
Yeah. Somallo, please wait. I'll say. Let VC
Okay.
sir. Let VC sir join. MD
Okay.
sir. MD sir is joining in 5 minutes.
Okay, sir.
Minds, empowering life within us tomorrow bright. We have one who thinks to win and achieve what we dream. We become the stormy seas, our courage becomes eternally. Our life is really our smart, our saving vision. GIS, the sky. We have what it takes to fly, and tonight the truth begins. We can put our foot on as we touch the sky. We have what it takes to fly, and tonight the truth begins. We can put our foot on. We have what it takes to fly, and tonight the truth begins. We have what it takes to fly.
Sakshar, get ready for on-board copy.
Sure, sir.
Sakshar on board, copy.
A very good morning to all the dignitaries, my colleagues, my beloved students. Myself, Sakshar Shah, as a coordinator of this event, I'm very pleased to welcome all of you in the first International E-Conference Colloquium 2020, organized by Department of Pharmaceutical Technology, Department of Chemistry, and Department of Biotechnology, JISU University. Your presence and participation is truly appreciable.
Sir, आ जाइए sir.
The crisis we are going through at this moment since last few months due to this unknown threat of human lives, it is a high time, I think, such an event should take place to highlight the recent innovation in pharmacy and green chemistry during post-COVID era, which is actually the theme of our conference. I would like to thank our organizing committee, our core organizing committee, for taking the initiative and making this event actually possible. Without their help and support, this day would not have been in reality. We have Mr. Taranjit Singh, Chancellor of JIS University, Managing Director of JIS Group India as Chief Patron. We have Mr. Simarpreet Singh, Director of JIS Group in Advisory Board. We have our Vice Chancellor, Dr. Biman Chandramal as Patron, our Dean, Dr. Tapan Kumar Chatterjee as Chairman, and the person who are there in every nook and corner of this event, our convener, Dr. Himanshu ji, Head of the Department of Pharmaceutical Technology, and all three organizing secretaries. Let me just take their names. Dr. Pinchu Kumar De, Associate Professor of Pharmacy Department, Dr. Otanu Kotal, Head of the Department of Chemistry, Dr. Moinat Mukhopadhyay, Head of the Biotechnology Department, and obviously my colleague, Mrs. Preeta Bose as Technical Coordinator. And a very small thanks will be very, very less for the scientific committee and its team, cultural committee and its team, and all the students volunteers. Without their help, without their effort, we would not have reached this time, I'm sure. So a big salute to all of them. So now I would like to I'd like to move on to our cultural section. Now we will be having an inaugural song which is made by our students. Due to the lockdown condition, we had to make the video earlier and we'll be sharing in front of you. So I'll request Shikha sir, so if you please play that. Ash.
A very good morning to all present here. Today, we have united through this online platform for our international e-conference. So, before starting, I would like to say a few lines from Rig Veda, a holy grantha. Rig Veda says, "Let us move on together without any division. Let us have equal exchange of thoughts, equal understanding. Let all of us be equal." Taking this in our mind, we will be proceeding for the program. Thank you.
श्वेत पद्मासना देवी श्वेत पुष्प पुष्पभूषिता श्वेतांबरधरानीता श्वेतगंगा श्वेताक्षशुद्धहस्ता श्वेतचन्दनचर्चिता श्वेतवीणाधरा शुभ्रा श्वेतकरभूषिता वन्दिता विधगन्धर्वैः चर्चिता देवदानवैः पूजिता मुनिभिः सर्वैः श्वेते सुजनानिनतां देवीं जगद्धात्रीं सरस्वतीं जे स्मरन्ते सन्धाय सर्वगीतं भवन्ति जय जय हे भगवती सुरभारती तब चरणों प्रणमामि जय जय हे भगवती सुरभारती भारती जय जय हे भगवती सुरभारती महाब्रह्ममयी जय वागेश्वरी महाब्रह्ममयी जय वाणेश्वरी स्वरनाते गच्छामः जय जय हे भगवती सुरभारती जय जय हे भगवती सुरभारती जय हे सरस्वती जय हे सरस्वती तमाशि शरण्या त्रिभुवनधन्या सुरमारि वन्दिता नभरा सुमधुर कविता मखरा स्मितरुचिरा वरा जय जय हे भगवती सुरभारती जय जय हे भगवती जय जय हे भगवती जय जय हे भगवती
शुभं करोति कल्याणं आरोग्यं धना संपदां शत्रुबुद्धि विनाशाय संध्यादीपं नमोस्तुते।
गच्छन्तु संवदन्तु संभूमनासि
ಅದು
Hello, hello.
topic.
Yes, sir.
Sakshar popcorn board.
Really mesmerizing. It was really very good to see. A big thanks to all of the students who made it and their guide, Mrs. JISU-PHARMA Gupta, the chairperson of the control committee. Thank you so much for this visual pleasure. So now I would like to request, we have already with us, uh, I would like to request our chief patron of Colloquium 2020, Mr. Taranjit Singh, Chancellor of JIS University and Managing Director of JIS Group India, to bless this event with his warm words and declare the program officially open. Sir, please. Taranjit, sir.
Good morning to everybody.
Good morning, sir.
Good morning, sir.
Hope everybody is well. So please start the program.
Yeah.
Sure, sir. Thank you, sir.
Thank you, sir.
Thank you, sir. Now, I would like to request our patron of Colloquium 2020, Dr. Biman Chandra Mal, Vice Chancellor of JIS University. Sir, if you please bless us for this event with your warm words. Sir.
Thank you. Am I audible?
Yes, sir.
Yes,
Okay.
sir, you're audible.
Good morning, everybody. I'm very happy that our Department of Pharmaceutical Technology, along with the departments of Chemistry and Biotechnology, is organizing an international e-conference on innovation in pharmacy and green chemistry during post-COVID-19 era. I congratulate the organizers for this because this is an unusual situation. So I know they have to face a lot of difficulty, but still they have took the courage to organize it. At first, I on behalf of the university. Hello, any problem? Okay.
No,
At first, I, on my personal behalf and on behalf of the university, welcome all the dignitaries. They include the invited guests, speakers, delegates, students, and others. We have among us Sardar Taranjit Singh Ji, who is the Honorable Chancellor of JIS University. We have Mr. Srimarpreet Singh, Director, Professor A.B. Bhattacharya, Pro-Vice Chancellor of this university, Professor T.K. Chatterjee, Dean of this university. We have Colonel B. Venkat, who is the Director, Faculty Development Cell of AICT New Delhi, Dr. Bhupender Goswami, he is the Eastern Regional Officer of AICT Kolkata. We have Professor Milan Palde, who was the Dean earlier of Faculty Medical Science Guru, Jama Basar University, Hisar. We have Professor P.V. Srinivasan, Director, Delhi Institute of Pharmaceutical Science, Professor P. Narasimham, Professor Mahasi, Dayanand University, Haryana. We have Professor Reddy, Y. Narasimha Reddy, Dean, Faculty of Pharmaceutical Sciences, from Warangal. We have Professor Monica Gulati, Dean, Lovely Professional University, Jalandhar. Professor Sanjay Kumar Sharma, who is the Associate Dean Research, Department of Chemistry, JECRC University, Jaipur. And then we have many eminent speakers, international speakers. We have Professor Dr. Om Tin U, who is a Professor, University of Technology from Malaysia. Then we have Professor Farkufom Panichai Pukarant, who is from Thailand. We have Dr. Jason Harwis, Associate Director, Health Outcome and Pharmacoeconomics, University of Arizona, Tucson, USA. Dr. Sanjay Kumar Sharma, he is the Associate Dean of Research, Department of Chemistry from Jaipur. Then we have Dr. Sandipan Bhattacharya, Associate Professor again from Arizona University, Arizona, USA. Professor Chiranjeev Pal, he is the professor from the State University of West Bengal, Barasat. Dr. Ranjan Jana, Principal Scientist and Ramanujam Fellow. He's from CSIR, ICB, Kolkata. Dr. Amitabh Ghosh, Health Educator, Inadik, Australia, Ply Limited from Australia. So that we have a huge gathering from different continents of this
Sakshar, copy. Voice is breaking.
Yeah, Saikot sir.
Yes, sir.
Yeah, VC sir has got a network connecting issue.
Yes, sir. We
Ladies
should
and
wait
gentlemen,
little
just
bit.
wait for a while.
He comes back.
Yes, sir will come.
Yes.
Hello, can you hear me?
Yes, sir has already come. Yes,
Yes,
sir.
sir.
Yes, sir. We can. We can.
There are 140 programs running, and we have more than 37,000 students under this group. This JIS Group Educational Institutes journey began some 20 years ago, though it has not been that easy, but it has made a very great success. And this university actually started functioning in 2015 August, when I joined as the first bachelor of the university. There are 11 departments in this university, namely Department of Pharmaceutical Technology, Hotel Management, Judicial Sciences, Biotechnology.
I think again, sir is having some network issue.
Courses in this department like pharmaceutics, PhD. From that we have other courses like multi and few certificate courses like pharmacovigilance, yoga, and naturopathy. The Department of Biotechnology started in the same year when the university started in 2015, and currently offers courses in at all the levels, bachelor, master, PhD level, both in biotechnology as well as in microbiology. The current specializations of the research includes nanoenzymatology, microbial biotechnology, downstream processing, biomass-based biofuel, cancer biology, etc. The Department of Chemistry also started its journey since the inception of this university. This department also offers BSc, MSc, and PhD degrees. The current thrust areas of research include polymer chemistry, material chemistry, organic synthesis, green chemistry, and coordination chemistry. This conference is on innovation of pharmacy and green chemistry during post-COVID era, 19 era. Now, to me at this moment, this seems to be most appropriate. The whole world is suffering from this deadly virus. The pharmacists have to think of the innovative and interdisciplinary research areas to tackle this problem. Green chemistry, also called sustainable chemistry, is an area of chemistry and chemical engineering focused on the design of products and processes that minimize or eliminate the use and generation of hazardous substances. Now, by understanding the properties and impacts of medicines and developing the skills required to counsel the patients about their use, pharmacists have the opportunity to improve the health and even save lives. Now, this kind of research is a little different. Earlier, it used to be in isolated areas and confined to few individuals only. But now it's not like that. People have to work together. We call the convergence of technology taking place. So I'll tell a little bit about the convergence of technology. The information technology and communication technology already converged, and it gave rise to ICT, or information and communication technology. Information technology combined with biotechnology has led to bioinformatics. Now nanotechnology has come in, and it is the field of the future that will replace the microelectronics and many fields, with tremendous application potential in the area of medicine, electronics, and material science. And I'm sure about the use of nanorobot for drug delivery. When nanotechnology and ICT meet, photonics are born, and it can be said that the material convergence will take place. Now, with the material convergence and biotechnology linked, a new science called intelligent bioscience is likely to be born which will lead to a disease-free, happy, and more intelligent human habitat with longevity and high human capabilities. Probably viruses like corona may not be able to attack human being at that time. Now, convergence of bio, nano, info technologies can lead to the development of nanorobots. And nanorobots, when that injected into patient, as I heard from the experts, that it will diagnose and deliver the treatment exclusively in the affected area, and then the nanorobot gets digested as it is a DNA-based product. And then talking about the post-genomic healthcare, we know that in biology, undoubtedly, one defining moment came in February 2001 when the draft human genome was published simultaneously by two different health groups, the research group. And by now, we all know that the human genome consists of about 3.3 billion nucleotides. But two human beings differ barely by just 0.1% of the genome. This is a very tiny variation, but still with this tiny variation, it is possible to explain precisely that how one human being is different from others. So it is actually possible to speak confidently about the personal medicine, whereby it is possible to fine-tune the drug dosages and treatment regimes to individual variation. But all this requires completely new science and technology that combines not only our pharmacy, but IT and DT also have to be there. And again, returning to the nanotechnology and its role in the post-genomic healthcare, we can say that one of the most important aspects of the drug delivery is people use
Sorry for the inconvenience. Our VC sir is having some network issue. We need to wait for a while.
Sakshar copy, please text to VC sir.
Hello, is it connected? Can you hear me?
Yes, sir, it's connected.
So it got
Yes,
disconnected
sir.
in between.
You're audible, sir.
What happened? So
Yes, sir, network issue.
okay.
Yes,
So I
sir.
just
You're audible, sir.
repeated. To insulin. The immunity working on protein will do the job of the insulin, but it can take care in just about, and that was promising as systematic design, delivery mechanism, formulation. It requires a deep understanding of how the body acts on the pill and how the drug acts on the body. So pharmacists, chemistry experts, biotechnologists, they have to collaborate with the electrical and electrical engineers, the methods people who have the deep knowledge of mathematics, simulation, and design optimization, which can play a major role in helping this technology to achieve its true potential. I once again welcome all the respected delegates, guests, speakers, media partners,
Sakshar copy.
Yes, sir.
Please ensure from
I
your
think,
end and text VC sir.
Sure, sir. We need to wait a while. He's trying to join again. I hope.
Ladies and gentlemen, just wait for a while. We are having some technical glitches from the VC sir's end. Please bear with us. Thank you.
Hello. Hello.
Yes, sir, you are audible.
Yes, sir, you're audible. You're audible, sir.
Network connection issues.
Don't know what. I can see Dr. Pale
This is,
there.
if you,
Yeah?
Sir, we can hear you. No
if you-
problem.
Yes,
Could you
sir.
hear the
Yes,
last
no
portion
problem.
of my lecture?
Yeah.
Could you hear last portion?
Yes, sir, we did, sir.
Okay,
We
you
did, sir,
that.
yes.
So once again, I welcome you all our respected.
স্যারের মোবাইল ইয়ে না ভিডিওটা বন্ধ করে দিতে পার, লাইন খাচ্ছে বেশি। স্যার আপনার ভিডিওটা বন্ধ করে দিন।
স্যার
ভিডিওটা বন্ধ করে
Yes,
দিতে পার, পারছে না টানতে।
VC sir, if you please switch off your video, then I think the amount of data will be consumed less. Yes,
right,
then we
right.
can hear you properly then.
Dr.
Yes,
Maji
sir.
Papi,
Yeah, sir, please.
can you please mute some of the videos, please, from your end?
Yeah, I'm doing. Constantly I'm doing.
ভিডিও বন্ধ করুন।
VC sir, I don't think is with us.
No, VC sir is there. VC sir is there.
Is there? Okay.
I cannot unmute. Professor
Professor Maji, can you please?
VC sir, can you hear? VC sir?
No?
Yeah, sir, VC sir?
Yes, we can hear.
Yeah, with your permission, sir, shall we continue?
Yeah.
I think so, don't anymore.
Akshar, copy.
Yes, sir.
Can you please text VC sir?
Yeah, I am calling. Sir?
Yes,
sir,
sir.
can you copy? Yeah.
Yeah, should we continue?
Yeah, I think with the permission of MD sir, we should continue. Sir, we are
Sure,
continuing.
sir. Sure.
Yeah.
Please continue.
Sure, sir.
Thank you, sir.
Sure, sir. Thank you, sir. Thank you. So I'm so sorry for the inconvenience happened from our end. VC sir was having some network issues. That's why he got disconnected.
Yeah,
But
please
for that-
continue. Please continue.
So now, yes, sure, sir. So now we are having, and I would like to request our chairman of Colloquium 2020, the International E-Conference, Dr. Topon Kumar Chatterjee. He's the Dean of JISU University. Sir, if you please say something for our conference and bless us for the same.
Thank you. Honorable Chancellor Sir, Chancellor of JISU University, Sardar Taranjit Singh, Vice Chancellor Professor B. Simal, Mr. Simarpreet Singh, Director of JISU Group Education Initiative, Professor, Pro Vice Chancellors, Professor A.B. Bhattacharya, Director Affairs, Dr. T.K. Saha, Professor Ajay Rai, Director of JIS IASR, Professor Ovijit Sengupta, Director GNIPST, Professor H.S. Maji, Head of the Department of Pharmacy of JIS University, Dr. Moinak Mukhopadhyay, Head of the Department of Biotechnology, JIS University, and Dr. Atunu Kotal, the head of the Department of Chemistry of the same university, and the eminent speakers, faculty members, and beloved students, very good morning. SARS-CoV-2, the virus that causes the COVID-19, is part of the coronavirus, that is RNA family. Due to this pandemic COVID-19 disease, all events around us have been shattered and world is locked down. I sense enormous content that the Department of Pharmacy, along with the Department of Chemistry and Biotechnology of JIS University, are jointly organizing the first ever international conference known as Colloquium 2020 on the theme Innovation in Pharmacy and Green Chemistry during post-COVID era. So the name, that is the Colloquium 2020, has a very great meaning. Colloquium means an academic meeting of the or seminar usually led by the different lecturers and on a different topic at each meeting. So we proudly focused on the theme unlock potentials of the JISU during lockdown by COVID-19 through our e-conference. So I will say coming together is a beginning. Keeping together is progress. Working together is success. And no task is big if worked as a team. Thank you. So I'll talk about the more, that is pharmacy innovation. As economics around the world are suffering from the impacts of the COVID-19, business are experiencing the losses, workers are without jobs, and many face the challenge of complete upheaval of the lifestyle. However, pharmaceutical companies taking center stage of the COVID-19 fight, such as Gilead and Eli Lilly, are seeing the positive growth on the stock market and a new burst of innovations in infectious disease landscape as the race for the treatment of approval for the COVID-19 therapy take off. So this will be the pictures in the post-COVID session. AstraZeneca, that is AZ, expects to see a drop in the revenue due to China's current economic position. But in face of this potential hit, AZ has announced a donation of the 9 million face mask to the various countries facing hard struggles with the virus and has ramped out the trials on diagnostic testing measures. Global data anticipates that AJ may be able to override this loss of revenue with the prospect of successful drug agents against COVID-19, such as their cancer treatment, COLLOQUIUM. The company is rapidly developing a clinical trial of the drug in COVID-19 patients. Furthermore, AZ has joined force with the Sanofi, another big company, in the hope of developing vaccine, another project that would help to regain loss of their revenue. So other pharmaceutical companies are following suit during the COVID-19 pandemics and post-COVID-19 and using their own capabilities to lighten their burden of coronavirus on their patients. Eli Lilly has offers great support to its diabetic population with full-fledged adverts in the various US papers dealing how they can receive support in such financially unstable times. Therefore, it has offered greater supports to those who have lost their jobs or insurance plans due to these virus. So patients are encouraged by the company Eli Lilly that they will supply their full support to the diabetic solution through their centers. Another point of interest is of the company Bayer is a big place in the pharmaceutical market, which has donated 3 million resources, that is the chloroquine tablets to US governments for use in COVID-19 patients. Novartis is also giving back to the population in time of the crisis, having committed to donating 130 million doses of the hydroxychloroquines to aid in the global pandemic situation and post-COVID situation. They will do more further research, and they will pour more money out of this profit to their research. So the pharmaceutical research will be very weak in futures. The Pfizer has also unexpectedly gained from the coronavirus outbreak. Pfizer's pneumonia vaccines, Plevnas 13 has been an unexpected jump in sales, most probably due to the course of the coronavirus, which is severe case caused the corona pneumonia with a high mortality rate. This increased revenue of the Pfizer's will be matched and extended to its collaborations with the biotech of global field for a COVID-19 vaccines in a near future with a successful manners. There are also unexpected entrants to the contents with such Kentucky Bioprocessing, a subsidiaries of the British Americans Tobacco, who are in preclinical stage with non-profit plant-based vaccine. That is also a very unique thing they have thought, and based on some biotechnology, they will do that. Gilead's, another company, potentially is the most beneficial and controversial of all COVID-19 fighting drug makers, has also made contributions to the COVID-19 battle. Remdesivir, the Gilead's promising antivirals has given the compassionate US programs CUP status and is one of the top-ranked drugs to help battle in the coronavirus crisis. It has had the positive results in the animal studies and also in those treated on its CUP. The drug was granted orphan drug status on March 25th, 2020 by FDA, which guarded them the heavy criticisms of the orphan drugs designations would also entitle huge tax benefit and the long potency period in which generic, cheaper and more accessible alternatives would not be permitted. AbbVie, another companies at a similar time, denoted all the incentives of the orphan drugs designated for the HIV antiviral Caletras, that is lepivarin and ritonavir, being trials on the coronavirus. So I think this is the times for the students of pharmaceuticals, chemistries, and others was doing their course in pharmacy along with the clinical pharmacies, that big market will open in near futures after the finish of these the black days of the COVID situation, that is in the post-COVID situation. Many more companies will come forward. They will pour monies for clinical research in futures. So I think the students will feel very good from this mind that what they are studying, they can at least contribute some things in futures. In their future generations will obviously benefited out of that. Thank you very much for giving me the chance for giving some things about that post-COVID research in worldwide. Thank you.
Thank you, Dean sir. Thank you so much. Thanks for your nice words. So now we are having amongst us Mr. Simarpit Singh, the director of JIS Group India. I would like to request Simarpit sir, sir, if you please say something for our event and bless us for our conference. Sir.
Good morning to all. It is my absolute pleasure
morning,
to be here today. I think it's one of the best things that our university has done in this COVID time, that we're the first university in Bengal to have an online conference, especially on the topic is very relevant in today's time. And there are a galaxy of speakers today, so I won't waste any of the time here by mentioning their name. I'm just very grateful that all the speakers have come here and all the people who are registered for this conference. I'm sure the conference will put into light the challenges of the post-COVID era, and we might find some solutions to it as well. And with this, I want to say thank you to the organizers. Thank you for inviting me, and I wish this all the best to this conference. Thank you.
Thank you, sir.
Thank you very
so
much.
much. Thanks for your time, sir. Thank you, sir. So now I would like to request to the person who are there from the beginning of this event, our convener of Colloquium 2020, Dr. Himanshu Shekhar Majhi, is the head of the Department of Pharmaceutical Technology. So I would like to request him, so if you please say something for our conference.
Thank you, Saksar. Good morning to all of you, ladies and gentlemen, honorable guests. Being the convener of the Colloquium 2020, the international conference organized by the Department of Pharmaceutical Technology, Department of Chemistry, and Department of Biotechnology, I, Dr. Himanshu Shekhar Majhi, would like to declare that the Colloquium 2020, the first online international conference of JIS University, is now open. As we open this conference, it gives us a great pleasure to welcome all of you. In particular, I would like to express my gratitude and warm welcome to our plenary and featured international and national speakers. I would like to express my heartfelt gratefulness to the Chief Patron of the Colloquium 2020, Sardar Taranjit Singh, who is the Chancellor of JIS University and Managing Director of the JIS Group. Patron, Professor Dr. B.C. Mal, who is the Vice Chancellor of JIS University. Chairman, Professor T.K. Chatterjee, the Dean of JIS University. Pro-Vice Chancellor, Professor A.B. Bhattacharya. And all three organizing secretary, Dr. P.K. De, Associate Professor for the Department of Pharmacy, Dr. Atunu Kotal, Head of the Department of Chemistry, Dr. Moinak Mukhopadhyay, Head of the Department of Biotechnology, for making this great conference into reality. I would like to welcome committee members, coordinators, and student volunteers, because without their support, today's event would not have been in reality. All of our speakers are very special and have been selected carefully so that all of you can have a variety of topics and benefit from their knowledge. Now, I would like to take this privilege to introduce them to you. Firstly, I would be happy to announce the name of one of the keynote speakers, Professor Dr. Wang Tin Wei, who is the Professor of Non-Destructive Biomedical and Pharmaceutical Research Center, I Promise, University Technology, Mara, Malaysia. Our second keynote speaker is Dr. Fark Hum Panichayopokarant, who is the Assistant Professor of Prince of Songkla University, Thailand. I am really very thankful to Dr. Wang and Dr. Fark Hum for your valuable time and presence. Now, I feel delighted to take the name of the eminent speakers of the plenary sessions also. We are blessed to have Colonel B. Venkat, who is the Director of Faculty Development Cell of All India Council of Technical Education, New Delhi. We have with us Professor Melin Parle, who is the former Dean and Faculty of Medical Science, Guru Jambeshwar University, Haryana. Professor Nitin Barma, who is the Principal of the School of Pharmacy, Chitkara University. Professor Ranjan Jana, Principal Scientist, Organic and Medicinal Chemistry Division of CSIR, Indian Institute of Chemical Biology, Kolkata. Dr. Chandrachur Ghosh, Instructor of the Harvard Medical School, Boston, USA. Professor Dr. Jason Harwich, Assistant Director of the Center of Health Outcomes and Pharmacoeconomics Research, University of Arizona, USA. Dr. Sumit Mukherjee, Key Accounts Manager, Life Science Division of IMI Precision Engineering, Bengaluru. Professor Sanjay Kumar Sharma, Associate Dean of Research, Department of Chemistry, JISU-PHARMA University, Rajasthan. Dr. Amitabh Ghosh, former professor, health educator, Energic Australia Private Limited, Australia. Dr. Chiranjit Pal, professor of the Department of Geology, West Bengal University, State University. Dr. Sandipan Bhattacharjee, assistant professor of the University of Arizona College of Pharmacy. Professor B. Narasimhan, professor of Maharshi Dayanand University, Rohtak, Haryana. Dr. Anuswa Hajra, director of Jensen Pharmaceuticals, USA. Dr. Mukesh Nandave, he is the professor of the first private pharmacy university, DPSRU, New Delhi, India. As you know, this is the first international e-conference organized by JIS University, which was established through the Legislative Act of the Government of West Bengal that came into force in February 2015. JIS University is the brainchild of the visionaries of the JIS Group Educational Initiative. It's the largest educational conglomerate of the Eastern India with 30 different institutions, 140 programs, 600 faculties, and a staggering of 40,000 students. The Department of Pharmaceutical Technology, JIS University, started functioning in 2016 with Bachelor of Pharmacy course with prior approval from the Pharmacy Council of India. Currently, we offer courses like D.Pharm, B.Pharm, M.Pharm, and PhD in Pharmacy. The department is equipped with latest analytical instruments like Hedolf, rotary evaporator, multi-station dissolution apparatus, Simarju, spectrophotometer, Bruker, FTIR, Agilent, HPLC, Appendrop, deep freezer, etc., etc. We have immense research focus on recent drug delivery system, herbal drug development, process development techniques, and drug analysis using spectrophotometric approach. The Department of Biotechnology offers courses such as bachelor's, master's, and PhD in biotechnology as well as microbiology. The current research areas of the department includes nanoenzymology, microbial biotechnology, downstream processing, biomass-based biofuel, cancer biology, evaluation of signaling pathways, and novel target responsible for oncogenesis, etc. The Department of Chemistry started its journey since the inception of the university, and it offers courses in bachelor's, master's, and PhD in chemistry. The current thrust area of the research include polymer chemistry, material chemistry, organic synthesis, green chemistry, and coordination chemistry. Now, to address the objective of the theme of our conference, that is recent innovation in pharmacy and green chemistry during the post-COVID-19 era, I would like to add a very few words. Innovation is a key word throughout the pharmaceutical industry and healthcare community. Advances in the healthcare technology have led to significant improvement in the quality of healthcare in population health, and in parallel have contributed to increase in real health expenditure in most industrialized countries over the recent decades. Green chemistry, also called the sustainable chemistry, in an area of chemical engineering focused on the designing of products and processes that minimize or eliminate the use of generation of hazardous substances. One of the major objectives of the conference is to make industry, scientists, academics collaborations to meet the major challenges of innovation in pharmacy and green chemistry during the post-COVID era. I want to mention one more special thing, that we have received around 3,367 registrations, and nearly 1,500 registrations are from the state of West Bengal, and remaining almost 2,000 are from other states of India. We have received around 50 registrations from Indonesia, Pakistan, Thailand, New Zealand, Zambia, and France. There are a total of 800 faculty members, 159 research scholars, 700 PG students, and 1,500 UG students, scientists, and industry professionals who are taking part in this conference through Zoom, YouTube, or Facebook live channel. We have received a staggering of 650 abstracts to be presented during oral and poster sessions. Best poster and oral presentations will be awarded. With a large number of participants, we are sure that this conference will be a memorable, highly educational, and a not to be missed event. We hope that this conference will help you better understand the science behind the innovation in pharmacy and green chemistry and obtain the knowledge necessary to improve the state of the subject. We truly value your participation and support for this conference. Thank you so much for joining and for your kind attention and participation. Thank you. Thank you all.
Thank you, Maji sir. Thanks a lot. Your words means a lot to us. So now I would like to move on, and I would like to request our next guest, Professor Dr. Bhupendra Goswami. He is the Director URO of All India Council of Technical Education, AICT, Kolkata, India, to say some words for our conference. Sir.
Am I audible?
Yes, sir. Yes, sir. Definitely,
Yes,
sir.
yes. Okay, okay.
It's so
So
nice
good
of you,
morning.
sir.
Yes,
Yeah.
good morning to all of you. I am very much thankful to the convener of the conference who has given me an opportunity to speak on this platform. Considering the present circumstances, I feel that we are quite fortunate that we could arrange this important conference through online and ensure transmission of knowledge without any hindrance. In the context of present situation, this type of program in pharmaceutical sectors will be the milestone of innovation. From the ancient times, innovation was done by human beings for the proficiency of their livelihood. Earlier innovation depend only on the practical experience and not on any scientific formula. If we look at the evolution of innovation in India, it is interesting to note that there is a kind of duality. There are formal and informal stream of innovation systems that are running in parallel, which need to be more often. The first innovation system was the formal R&D based, science-based innovation system, which was given a huge push by the government after independence as a part of India's effort to become part of the global science and technology community. A major part of this system is in the informal sector, but some of this resides in formal sector as well. It has contributed a lot to health well-being in India. The focus is here largely on industrial innovation, and the Indian company have made sincere innovation effort in some domains, particularly in pharmaceutical industry. Ministry of Innovation Cell has focused on creating a complete ecosystem to foster the culture of innovation across all educational institutions, from generation of idea to pre-incubation, incubation, and graduating from the incubator as successful startup. MIC has also worked on designing ranking system to identify institutions in the forefront of innovation. Smart India Hackathon is a nationwide initiative to provide students a platform to solve some of the pressing problems they face their daily lives and inculcate a culture of product innovation and a problem-solving mindset. Through the hackathon, PSU and NGO aim to create world-class solutions for some of the top organizations, including industry in the world, thus helping the private sector hire the best minds from across the nation. It can help to harness creativity and expertise of students, spark institute level hackathons, build funnel for Startup India campaign, crowdsource solution of improving governance and quality of life, provide opportunity to citizens to provide innovative solution to India's daunting problems. The first edition of 2017, 2018, and 2019 have proved extremely successful in promoting innovation in young minds, especially engineering students from across India. Ministry of HRD has established Ministry of HRD's Innovation Cell at the AICT headquarters with the mandate to work closely with our higher education institutions to encourage the creative energy of our student population to work on new idea and innovation and promote them to create startup and entrepreneurial ventures. Agriculture and rural development, clean water, food technology, healthcare, biomedical devices, life science solution, skill development, waste management, etc. are the major outcome of the innovation cell. I hope the participant of the conference will get the maximum benefit from these programs. I would also like to convey my best wishes for an effective, productive, and successful of the program. Thank you.
Thank you, sir. Thanks a lot. Thanks for your words, sir. Now, yes, sir. Now, I would like to call and request Professor Dr. Y. Narasimha Reddy. He is the professor of Kakatiya University, India, to say some words for our conference. Sir.
Hello, good morning. Is it audible?
Yes, sir.
Yes, sir, it's audible, sir. Good morning, sir.
Sir. Sir, very good morning.
Perfect.
A very good morning. The respected members, Sri Taranjit Singh, Chancellor of JIS University, BC Mall, Vice Chancellor, and TK Chatterjee, Dean, and Mr. Simapreet Singh, Director, and Dr. S. Maji, Convener, HOD Pharmacy, Professor Bhupendra Goswami, Director, ERO AICT, Dr. Monica Gulati, Dean LPU, Dr. Sunil Kaushal, MD, Professor Milind Parle, ex-Dean, Guru Jambeshwara University, Istar, Haryana. So I am very happy, and first of all, my hearty congratulations to JS University for organizing a wonderful program that is Colloquium 2020. This is the first time conducting this international e-conference. So it is very great. First of all, I want to congratulate the organizers for keeping the wonderful theme, that is innovation in pharmacy and green chemistry during post-COVID-19 era. And more than 3,000 delegates registered for this program to participate in this event, and more than 50 the e-oral presentations selected, and more than 200 e-posters for the presentation selected, and also encouraging giving the prizes for the winners. And they are inviting the eminent speakers from abroad, and also India and USA, Thailand, Malaysia.
இதெல்லாம் முடிஞ்சிச்சு மேத்ஸ் மட்டும்தான் மேத்ஸ் வந்து புரியல
Yeah.
Sir.
Yes, sir.
Copy.
Dr.
Can you
Red.
proceed? Yeah, I think
Sure, sir. So, Dr. Reddy is with us.
I think we should proceed. Dr. Parle and Monica ma'am is waiting. Thank you.
Sure, sir. Thank you, Dr. Reddy. Thanks a lot. Now we are having amongst us Dr. Monica Gulati. She is the Dean of Lovely Professional University. It is in Jalandhar, Punjab, India. I would like to request Dr. Gulati, ma'am, if you please say something for our conference and bless us for the same. Ma'am. Dr. Gulati, am I audible?
Yeah, ma'am has joined in unmute mode. I think I'll call her.
Yes, sir.
Yeah, sir is waiting.
So,
yeah, you proceed, please.
Sure. So we'll be connecting with Dr. Gulati very soon. So till then, we are having amongst us Dr. Miran Parley. He is the ex-dean and faculty of medical sciences, Guru Jambheshwar University, Haryana, India. I would like to request Dr. Parley,
Yeah,
sir,
ma'am,
if you
you
please
have
say
joined
something for our
through mute
conference.
mode. Kindly log out and log in
Dr.
again.
Parley, sir. Dr. Parley, you are in mute mode. You have to unmute. Sir, if you please unmute Dr. Parley. Mari, sir.
Good morning, one and all.
Good morning, sir.
Right.
Good morning, sir. Good morning, sir.
At the outset, I am privileged, to be with JIS University. I congratulate the organizers, respected Chancellor, Vice Chancellor, officers of the university, and my friend, Dr. Himanshu Maji. Thank you so much. Now, this conference I find has two aspects in the theme. One is green chemistry, other is innovations in pharmacy. Very relevant. We require a green planet. We are in post-COVID era. The birth of coronavirus has taken place because we are no more green. We need to take efforts in this direction. And the first part is about innovations. Innovations in pharmacy. I shall be deliberating in detail in the afternoon session in my plenary lecture at 2:30 p.m. today about innovations. Briefly, let me tell you, we all hear the words invention, innovations, creativity, discovery without really understanding them. There is a subtle difference. Discovery is something which already exists and you have seen for the first time. For example, you take a morning walk in the morning in a garden and you see a bluebird. The bluebird is already there on earth. The garden is already there. You have spotted it for the first time. This is discovery. Whereas invention is something producing new, something which you are manufacturing, producing, fabricating, or designing for the first time, which never existed on earth. That is invention. Now, in order to have, discovery or to be an inventor, you need to be highly innovative. Innovation is must. See, Alexander Fleming discovered penicillin, or Thomas Edison discovered electric bulb. It was possible because they were innovative. And let me tell you, each one sitting here, I understand there are around 3,000 delegates and many resource persons. Each one of you can be innovative. I'm going to share the success story of my laboratory in my talk with the aid of slides in the afternoon. To become innovative, you have to just think out of the box. It is possible. You should think freely. You should be able to experiment freely, totally stress-free, and you are innovative. If you are innovative, you are the leader. If you are not innovative, you will be the follower. If you are not going to invent something, somebody else is going to innovate it for you. So it's very important. Just think in an absurd manner. And when you work on this absurd idea, it becomes an outstanding idea. When you start refining ordinary things, they become extraordinary. So I thank the organizers once again for allowing me to share my experience with you. And I wish the proceedings of the conference are beneficial to one and all. Thanks. Thank you very much.
Thank you, sir. Thank you so much. Thanks for your wish, sir. So now I think
yeah,
we are having...
Monica ma'am is there. Monica ma'am is online.
Yeah, sure, sir.
Yeah.
Sure, sir. Sure, sir. So now I would like to request Dr. Monica Gulati, the Dean of Lovely Professional University, Jalandhar, Punjab, India. Ma'am, if you please share your thoughts with us for the conference. Ma'am, please.
Very good afternoon to all my friends. I hope you are able to hear me.
Yes, ma'am.
Yes, ma'am. You're audible, ma'am. You're audible. Good morning, ma'am.
To all my friends, and though I understand that lockdown has been a very difficult time, but I'm thankful to the organizers and I'm thankful to Dr. Pintu and Dr. Maji for involving me in the conference. Now, regarding my message to all the delegates, I would like to say that I understand that, of course, it has been very unfortunate. The lockdown has changed our world forever. It is not for a day, for a month. It has changed our lives, all of us, forever. But certain certain good things have happened for your profession. For a pharmacy profession, the opportunities have never been like this. There have been news that, the FDA gives approval in 10 days. It has never happened earlier in the history of India. FDA used to take many months, many years at times to give approval. One thing. Second thing is, we are in limelight. We have been labeled as the pharmacy of the world. India has supplied the life-saving drugs to more than 127 countries in last 1.5 months, and the opportunities have never been so good earlier. Now what happens is, we were, along with China, we were known as the India tsunami. I don't know whether you people know it or not. China plus India, they used to call us India tsunami, as we had captured almost 70% of the market. And in generics, we were always dominating. So now with China practically blacklisted by the entire world, you as the upcoming pharmacist, you stand a very good chance to rise in your profession. Now what happened? When the lockdown started, there was the downfall in the working of all companies except pharmacy companies. Pharmaceutical companies, they never stopped working, right? The share markets, they crashed for all companies except pharmaceutical companies. So I heard that, for Biocon, for Cadila, the shares went up. Then another very, relevant parameter for your generation, for the younger generation, is the Google traffic. The Google traffic for all parameters went down except nutraceuticals, except pharmaceuticals, and what? Insurance. So you see, we have an unprecedented opportunity lying ahead of us. Only thing is we need to act now. We cannot wait. Already an opportunity which was there for the manufacture of a few drugs from Gilead, it has gone to Bangladesh. So it is for you people to act immediately. Take stock of the...
তুমি যে মিউট অপশন ভিডিও গুলো কিছু আসছে না আমার অপশন
I would like to request all of the participants to put yourself on mute mode. Please put yourself on mute mode.
শুভেন্দু দেব
Galaxy J7 Max, please mute yourself.
অফ মানে মিউট আনমিউট করে রেখেছে, ওটা দেখাচ্ছে, আজই দেখাচ্ছে না।
Yeah, let me check, sir. Ma'am, please continue, ma'am.
Sure, sir.
So I was actually saying that, for us, for pharmacists who have been the forerunners in this time, in this era of lockdown, probably, your children will learn this in history. We have an unprecedented opportunity lying in front of us. and it is up to us. For other people, the salaries are being reduced, the salaries are being cut, there have been layoffs, but for pharmacists, the opportunities have increased. There have been a lot of recruitment. Salary 75% more salaries have been given by certain companies in Baddi. Why? Because the pressure has suddenly increased. In fact, final year students have been recruited as the COVID warriors, and they have been paid 1,000 per day when they have not even yet earned the B.Pharm degree. So you see the kind of opportunities you have in front of you. Don't feel bad about it. Feel more energized, feel more motivated, and do your best. If you put your best step forward, I don't think anybody can stop you, and you can, harvest this golden opportunity. So all my best wishes to all the student delegates, to all the organizers for the tremendous success of this conference. This is really, what do I say? This is really an unprecedented again and a very unique kind of effort on the part of the organizers. And I wish uh, complete success to the organizers. Thank you.
Thank you, ma'am. Thank you so much, and thank you for raising the points of the condition of pharmacists for this situation, due to this situation. And thank you so much for this topic, ma'am. Thanks a lot.
God
So
bless the
now
conference.
we are having. Thank you, ma'am. Your wish means a lot to us. Thank you so much, ma'am. Now we are having the session for our keynote speaker, and I would like to hand over the session to my colleague and technical coordinator, Mrs. Preeta Bo. Preeta, please.
Thank you, Sakshar. Am I audible?
Preeta, am I audible? Yes, you are audible. Please go ahead. Thank you.
Honorable Chancellor Sir, Vice Chancellor Sir, Pro VC Sir, Dean Sir, Director of Affairs, all HODs, the dignitaries, participants and listeners present out here. A very good morning to all of you. I, Preeta Bose, Assistant Professor and Technical Coordinator of Colloquium 2020, welcome you all to this bright and beautiful first day of our international e-conference organized by Department of Pharmaceutical Technology, Chemistry and Biotechnology, JIS University. I am feeling very privileged to introduce our first keynote speaker of the day, Professor Tin Vui Wong. He is a lecturer and researcher at the Non-Destructive Biomedical and Pharmaceutical Research Center, I Promise, University Technology Mara. His research areas are primarily focused on particle scaffold design for oral, transdermal, and pulmonary drug delivery, development of non-destructive pharmaceutical analyzers, as well as design of pharmaceutical processors for innovative dosage form manufacture. He has published over 110 peer-reviewed articles. He is the editorial board member of Asian Journal of Pharmaceutical Sciences, associate editor of Drug Development and Industrial Pharmacy, and chief of recent patents on drug delivery and formulation. He has served as a reviewer for more than 100 international journals like International Journal of Pharmaceutics, ACS, Applied Materials and Interfaces, and expert opinion on drug delivery, pharmaceutical research, nanoscale. Professor Wong is the advisory board member, outstanding scientist jury, lead judge for several international conference and innovation awards. Innova Pharma Tech Scientist Award, Malaysia Technology Expo Innovation of Singapore, and lecture professor of Zhangzhou University, China. He obtained his PhD degree from the National University of Singapore in 1999. I would now request Professor Tin Vui Wong to please lead us into our first session for today.
Okay.
Sir?
Yeah, thank you very much. And I hope all of you can hear me. And I have actually switched on my WhatsApp. So I think Prof. Maji has my number.
Yes, sir.
If there's sessions interruption, please feel free to call me. Alternatively, you can unmute. Then I will know that there's an interruption. Let me share my screen. All right. Just would like to double check. Can you see the screen?
Yes, sir. It's visible.
All right. And allow me to keep the screen as it is. If I enlarge it, you will actually have a delay and lag time between my voice and the image. So I will keep this screen as it is.
It's okay, sir.
Yeah. So first of all, I wish to thank Prof. Chatterjee, Prof. Maji for the invitation and kind arrangement for me to have the opportunity to share some of the research findings in Malaysia. So this morning, I wish to share with you all on the current progress in skin delivery of small molecule as well as macromolecular drugs for cancer and diabetes treatment. So I will first touch on the skin cancer in today's presentations on cutaneous melanoma. So skin cancer is one of the most common malignancies of human. Occurs mostly in white population. Over 1 million cutaneous melanoma cases have been detected per year. Now the reasons can be multiple, involve multifactorial pathogenesis, with ultraviolet radiation being the main culprit. Now what about Asia population? Now we do have patients contracting skin cancer, contracting cutaneous melanoma, but in a different form. So the melanoma the Asian population has encountered is the acral lentiginous melanoma, occur mostly at palm and sole, and for a different reason. It's not because of a UV radiation, but more of the local trauma and agricultural chemicals. And malignant melanoma is one of the most aggressive types of skin cancer, occur primarily through proliferations of melanocyte at the epidermis and dermis junctions. Now you can see the next slide, the skin surface morphology of cutaneous melanoma. Now this melanoma may first develop near the epidermis. Now with time, without proper treatments and diagnosis, it can actually grow deeper, going down to the upper dermis, lower dermis, and subsequently, it may metastasize into the bloodstream. So in the case of Southeast Asia, you will see that Singapore, Brunei has increasing cases of malignant melanoma. Now, sorry, I don't know why there's a red light automatically shown on the screen. Now, what about Indonesia, Malaysia, Philippines? Now, what we realize is there's an increasing incidence of UV-related cataracts. Now, this is a sign whereby malignant melanoma cases could probably be building up in Indonesia, Malaysia, and Philippines. So melanoma is commonly overlooked and undertreated in Asia population. Now, for Asian melanoma patients, usually they have a very late diagnosis. So by the time they are diagnosed with melanoma, it could be progressed into the advanced stage. Hence, they have a poorer prognosis than the Caucasian patients. Now, treatment of cancer, skin cancer, involve multiple modes. It could be surgery, radiation therapy, or cryotherapy, or it could be involved cancer chemotherapeutics through topical therapy for local treatments of cutaneous melanoma. Now, various drugs has been advocated for use. It could be biologics or small molecule drugs. And what we realize is that 5-fluorouracil, a very conventional cancer chemotherapeutic, has lately been identified as the potential candidates for cutaneous melanoma. So it is actually functional for skin cancer, in addition to other cancers such as colorectal cancer. But to deliver drugs such as 5-fluorouracil, though small, but it's highly hydrophilic, I think one of the main challenges is skin can act as a penetration barriers to the drug transport. Now let's take a look on the screen. On the skin itself, apology for the red dots. I'm not sure why it suddenly turns up. Yeah. Now skin basically has 3 layers: epidermis, dermis, and subcutaneous tissue. Now the top layer of the skin is known as stratum corneum. Now this is the primary penetration barriers to the drugs transport. Now, from the perspective of a pharmaceutical technologies, you will see that skin drug delivery is mediated through a few mechanisms, either through passive or direct diffusions through the stratum corneum and epidermis into the dermis and the bloodstream, or it can be through hair follicle and sweat glands. But knowing that hair follicle and sweat gland occupy only 0.1% of the total skin area, hence we actually identify diffusions through epidermis and stratum corneum is the primary drug administration routes for skin delivery. Now, knowing that stratum corneum play a role to deter or defer to delays the drug transport. Now, let's take a closer look at the structure or the construct of the stratum corneum. Now, you will see that stratum corneum actually is made from keratin-rich corneocyte. Now, embedded in a very systematic order in the lipid matrix, which is the pink in color, right? In the bricks and mortar fashion. Now, this lipid matrix, if you look closely, actually it consists of aqueous pore alternating with lipid bilayer. Now, the lipid bilayers is constituted of fatty acids, ceramide, and cholesterol. Now, though they are lipidic in nature, I wish to highlight to you lipid material such as ceramide does contain OH, NH, or carbonyl group that introduce hydrophilicity to the lipid bilayer. So transportation of drugs across the stratum corneum is rather challenging. It can be mediated through 2 pathways, transcellular and intracellular. Now you can imagine the drugs needs to transport through layers and layers of corneocyte. It will not be easy. Likewise, if the drugs is transporting through the aqueous pore of the intracellular routes, now this route is tortuous, is twist and turn. Again, it will not be easy. So over the years, we do gather experience that we need to transiently disturb the skin structure, the skin systematic structure, to enable the drugs, especially macromolecular drugs, to penetrate across the skin. Of course, this disturbance should be transient, and later on the skin should reseal in order to act as the protective barriers against external toxins. So over the past 30 years, if you look through the patents and literatures, 2 broad technology has been invented, passive and active. Now, the passive technology refers mostly on the formulations. You could actually hydrate the skins with dosage form that contains water. Now, this water can actually engorge in the aqueous pore of the skin, making the aqueous pore of the skin larger, thus allow more drugs to go through the skin. Now, alternatively, your formulation may contain oleic acid, ethanol, and surfactant. Now, this chemical can actually fluidize the lipid layers or extract the lipid layers from the skin, thus allowing a larger aqueous pores to be formed and more drugs can enter into the skin. Last but not least, of course, nanocarrier, which is the hottest topics of today. The nanocarrier basically can make from water, oleic acid, ethanol, or surfactant. Hence, through using these chemicals, they can actually mobilize, fluidize, or extract the lipid bilayer to allow larger aqueous pore formation for drug penetration. Now, nanocarriers, just by looking at its name, is small in geometry. Nanocarrier itself can also penetrate through the aqueous pore, entering into the dermis and releasing the drugs for the treatment of melanoma. Now, what about active technology? The simple techniques, a very conventional technique is using adhesive tape to remove the stratum corneum. Of course, this is highly undesirable in terms of patient application. Of course, the late inventions we have is microneedles, where you make the skin porous through using the needles, very small needles. You can use electrical methods such as iontophoresis and electroporation, ultrasound like sonophoresis, and some of the wave and gases. Now, for today's presentation, later on, I wish to highlight to you, we are going to combine microwave, which is an active technology, together with the passive technology, which is a nano carrier formulations to enable skin transport of the drugs, both small molecule as well as the macromolecule. Now, this microwave technology represents the latest active technology. It has yet to be commercialized. Currently, we are looking at the potential for use. Now, let's take a brief look on how the nano carriers deliver the drugs. Now, you will see that the delivery of the drug by nano carrier is very simple. The nano carrier either release the drug onto the surfaces of the skin, and the drug later diffuse across the stratum corneum into the epidermis and dermis. Alternatively, the nano carrier being soft and deformable, it can actually merge and fuse with the stratum corneum and release the drugs thereafter. Of course, some of the nano carrier with the suitable geometry, it can actually penetrate through the epidermis and dermis of the skin and release the drugs in the lower part of the skin. Now, the skin drug transport of drugs that is encapsulated within the nano carriers is being transported in a way that depending on the size as well as zeta potentials of the nano carrier. Now, skin drug transport, of course, is affected by multi-factors. It could be your skin construct and anatomy. It could be the environment such as humidities and temperatures. And of course, one of the major determinants of skin drug transport is still the nano carrier's design, particularly the size and surface charges, which is known as a zeta potential. Now, we have actually run through a systematic review. Now, in this slide, you will see that, of course, a lot of small nano carriers, they may be transported in a better way to a greater propensities through the skin. However, looking through the entire data, you will realize that there are a lot of small nano carrier are also having a very low transportation propensity across the skin. Hence, the relationship between the nano carrier size and the skin drug transport propensity is not straightforward. Likewise, if we look at the relationship between the zeta potential of the nano carrier with the skin drug transport propensity, the relationship is not simple and straightforward either. Now, with reference to vesicular carriers such as liposome, attosome, polymersome, transversome, attosome, there's no direct relationship between zeta potential and skin drug transport. Now, in the case of nano emulsion, we realize that majority of the nano emulsion with a zeta potentials of about -10 to -20 millivolt, it tends to promote skin drug transport. Now, what about polysaccharides nanoparticles such as alginate, pectin, or chitosan, or even some of the synthetic nanoparticles? Now, you will realize that positively charged nanoparticles or negatively charged nanoparticles, they tend to be able to transport the drug across the skin to a greater extent. Now, in the case of positively charged nanoparticles, it's not difficult to imagine because our skin is basically made from anionic lipids. Our skin is negatively charged. So using positively charged nanoparticles, these nanoparticles can get attracted to the skin very easily. And the nanoparticle and the drug itself can penetrate through the skin rather easily. Now, what about negatively charged nanoemulsion and negatively charged polysaccharide nanoparticles? Now, being negatively charged in nature, they can actually repel the anionic lipids in the skin. So as a result, the lipid bilayers of the skin will turn softer. This may allow the formations of larger skin aqueous pore and more drug hence can penetrate through the skin, right? So you can see that there's a complexity how a nanocarrier design can affect the skin drug transport. So with this in mind, commonly for skin delivery scientists, we usually wish to combine passive technology such as nanocarrier formulation with an active technology. Now in today's presentation, we are actually looking into microwave as the potential active technology to treat the skin, to permeabilize the skin so that they can allow more nanocarrier and drugs to go through without or with less dependence on the nanocarrier property such as size and zeta potential. Now you may wonder why in our laboratory we select microwave as a potential skin penetration enhancer because in the year of 2000 we actually use microwave to modify the solid medicine such as microsphere, polymeric beads or tablets. Now we realize that the microwave is able to interact with polysaccharide, protein, lipids of the solid dosage form. Now it can actually bring about some conformational changes to all these polymers and hence allow polymer-polymer interaction or polymer-polymer de-interaction. And all in all, it will actually promote a controlled drug release property. So with this in mind, when we look at the skin does have protein, the skin does have lipids. So we foresee that microwave may be able to soften or fluidize the lipid bilayer of the skin, hence to enable formation of larger aquospore, and that will give us the answer for us to pierce through the nanocarrier through the skin in an easier manner, right? So this is how the innovations ideas comes about. Now, if you look at the medical practitioners, microwave has been used now for cancer treatment, for removal of cancer, or for relief, joint stiffness or pain, or to warm up the tissue for relaxation, as well as to kill the microorganisms following surgery or wound treatment. So use of microwave in medical field is not abnormal, but use of microwave in drug delivery, this is one of the first studies globally. Now in year 2000, we do use microwave to control the drug delivery's mechanisms and kinetics through the microwave ability to heat, to elasticize, to induce cross-link coadjuvation or denaturation of polymer matrix. So you can see the intensity of microwave irradiation U is very high. It's 80 to 975 watt. The duration is very long, up to 60 minutes, and it can involve in multiple cycles. Now, all these microwave conditions for solid medicines modification, of course, is not suitable if you want to apply onto the skin to permeabilize the skin, so it may hurt the skin. So a brief literature search through intellectual properties as well as the journals, we realized that the general microwave exposure limit should keep below 1 milliwatt per cm square. And through theory development, we know that higher frequency microwave is preferable because higher frequency microwave will have a lower wavelength. It will stay on the surfaces of the skin rather than penetrate into the internal organ. And of course, the duration of the irradiation, we have to keep as short as possible to avoid any side effect to the skin or distant organ. So with this in mind, we actually move on to a preliminary experiment. Now we treat the rat skin with microwave of a different frequency as well as radiation. Now you can see that using the right frequency, such as 2450 megahertz, and of the right duration, such as 5 minutes, you will realize compared to untreated skin, the surface of the stratum corneum turns smoother. So this implies that perhaps the systematic structure of the stratum corneum, the bricks and mortar structure of the stratum corneum can be collapsed, can be broken down by the microwave. Hence, this will allow us to deliver small molecule and perhaps macromolecular drugs. So with all this search of literatures and also preliminary experiment, we then move on to create some experiments, some investigation with respects to cancer therapeutics. So in the first experiments, we use 5-fluorouracil because it's not easy to deliver a polar drug across the skin. Now we developed the 5-fluorouracil into Etosome with the aim to promote skin drug retention locally to treat the skin melanoma, and we wish to avoid drug permeation into the bloodstream because in this study, we are not targeting at the metastasized tumors. So we wish to treat the skin melanoma locally. So we have designed 3 variants of Etosome from the low ethanol content, which is 5%, to the high ethanol content of Etosome, which has about 15% of ethanol. Now you can see that when the ethanol content is high, such as 10 and 15%, it's easier for the 5-fluorouracils to be released. And also the 5-fluorouracils is easier to permeate into the skin, through the skin and into the systemic circulation. Hence, through this study, we realized that preparing Etosome using low ethanol content, such as 5%, is favorable. First, it doesn't raise the 5-fluorouracil permeations too much, but it can actually promote the skin drug retentions to a higher extent than E10 and E15. And we further the experiments through Fourier transform infrared imaging to find out why E5 can cause a higher skin drug retention. Now you realize that for E5, the low ethanol contents Etosome, a lot of Etosome can actually accumulate in the epidermis, unlike E10 and E15. Now looking at the physical data, such as size and zeta potential, now this is not difficult to imagine. Now you can see that E5 is larger in size, they are more negative, although they are able to penetrate the skin, but majority of them will stay in the epidermis, right? So because they will experience a greater repulsions from the anionic lipids of the skin. So most of them can penetrate, but they stay in the skin rather than going into the bloodstream. Hence, E5 is rather favorable when local treatment of melanoma is concerned. All right. So you may wonder, since the E5, low ethanol contents Etosome is preferred, now should we actually move on to prepare perhaps the E1 or E0.5 with an extremely low ethanol content? Now the answer is no, and it's highly unfavorable, because when the ethanol content is low, what happens is that the Etosome itself are being less elastic. So it's harder for them to squeeze through the intercellular pathway. So with that in mind, we actually decide to keep the Etosome formulated with 5% ethanol, right? Now, in an earlier experiment of us, we actually have one interesting observation. Now, you can see that if we treat the skin, the stratum corneum with microwave, now what we realize is that the intercellular pathway of the skin will turn larger, the aqueous pore turn larger. Now, treatment of the skin by microwave, followed by the application of a solid medicine, such as a solid film, you can see that the drug is released from the solid film, and they can actually penetrate down the intercellular roots rather easily, right? So a lot of drugs can be penetrated through the skin and into the systemic circulation. Now, the same experiment when we repeat, but with the application of semi-solid hydrogel medicines, now we realize a very different scenario has actually taken place. Now you will see that the intercellular roots of the skin is larger. The drugs will be penetrating into the skin, but the small polymeric molecules of the semi-solid hydrogel, it does have the flexibility and the mobility to penetrate through the intercellular roots. So the summative effect is that this small polymeric molecule acting like a cement, binding the small molecule drugs within the upper part of the skin. So this scenario is particularly viable and interesting to us when we want to retain the 5 fluorouracil cells in the epidermis and the upper dermis, right? So with this in mind, we actually thinking if we combine the use of microwave as the skin penetration enhancer, followed by the application of a liquid dosage form such as Etosom, we will be able to actually contain the 5 fluorouracil at the top part of the skin without them penetrate into the bloodstream to elicit any undesirable systemic side effect. With that in mind, we move on to some in vitro experiments using some skin from the rats. Now we realized that our hypothesis is indeed workable. You could see that treating the skin with microwave at 2450 megahertz for 2.5 minutes, followed by the applications of E5, the skin drug permeation is not increased drastically. However, these treatments of microwave followed by the application of E5 can promote skin drug retention substantially and significantly. So this is the good news to us. It's a first successful observation. Then we move on to execute FTIR imaging. So we realize the same observation is obtained as E5, but with a greater accumulations of E5 if the skin is being treated with microwave. And to examine the microstructural changes of the skin and how this facilitates the entry of the Etosom and drug into the skin, we actually conduct a DSC, differential scanning calorimetry, as well as FTIR, Fourier transform infrared spectroscopy analysis on the skin. Now, on the untreated skin, as well as skin treated by microwave, treated by Etosom, or treated by combinations of microwave followed by Etosom. Now, we are looking at the lipidic regime as well as protein regimes of the skin. We are also looking at how the epidermis and dermis respond to the Etosom as well as to the microwave. Now, to better illustrate the outcome, instead of looking at the numerical value, allow me to use this schematic diagrams to illustrate to you. Now, earlier on, I have described stratum corneum basically is the keratin-rich corneocyte arranged systematically with intercellular aqueous pore and lipid bilayer. And this epidermis is supported by dermis at the lower part of the epidermis. And treating of skin by microwave, what you will realize is that the keratin itself will actually convert from alpha helix to beta sheets, and they will be condensing. As a result, the corneocyte will be shrink into a smaller corneocyte. Apart from that, the intercellular lipid, due to its interaction with the microwave, it can actually being fluidized, turning softer, and the summative observation, you will have a larger aqueous pore. And this larger aqueous pore will actually have the nano carrier Etosom as well as the drugs penetrations at a greater ease and to a greater extent. Now, the treatment of skin by the microwave at the same time also bring about another effect. Now, microwave is a volumetric heating tool. It can actually radiate and penetrate the skin in a split second. So this microwave is also being found from our FTIR study, possibly interact with the extracellular matrix such as a protein like elastin. And these proteins may be swell, forming a barrier below the epidermis. So all in all, what you could see is that treating the skin with microwave, it allows the formation of larger aqueous pore that more nanocarrier and drugs can go through. But this nanocarrier and drugs may be able to penetrate the stratum corneum and epidermis. They may be able to reach the upper dermis, but they will not be able to go further down to the deeper dermis as well as systemic circulation because of the hindrance in the lower dermis as a result of the formation of swollen extracellular matrix. So this is tentative conclusions that we have obtained. We are running more experiments to verify the findings. Now, we also conducted in vivo studies in order to further concrete our in vitro data. Now, in these studies, we actually treat the live rats with ectosome or with microwave of the right frequency and duration, followed by the applications of E5 ectosome. Now, you can see that treating the skin with microwave first, followed by ectosome, there's very low level of plasma concentrations of drugs. And most of the drugs are actually being accumulated in the skin. So this is highly favorable when local treatment of melanoma is concerned. Now, we also conducted another experiment looking how the microwave interacting with the melanoma cell line, human melanoma cell line. So we realized that the melanoma cell line is thus responsive to drug-loaded ectosome as well as microwave. So both microwave and ectosome can actually kill the cancer cell to some extent. Now, combination of both appears to promote synergistically the cytotoxicity effect. And we further examine how the melanoma cell lines responds to this ectosome and microwave to enable a higher level of cytotoxicity. So we actually conducted DSC and FTIR testing on the melanoma cell line, on the freeze-dried melanoma cell line. So we realized that if we treat the melanoma cell line with microwave, with ectosome E5, or with the combinations of microwave and ectosome especially, it can actually fluidize the lipidic regimes of the skin as reflected by the reduced enthalpy value. And this ectosome can also interact to a greater extent with the phosphate moiety of the membrane of the melanoma cells. So the melanoma membrane actually is being fluidized because it does constitute lipid and phosphate moiety. And this fluidization of membrane perhaps open up the pores, allow more ectosomes to enter into the cell and have a higher level of cytotoxicity. Now we further concrete the cell line findings with a confocal electron microscopy study. Now you can see that treating the melanoma cell line with microwave followed by the ectosome enable a higher entrapment of the ectosome within the melanoma cell line and hence a higher level of cytotoxicity. Now we further examine how this microwave can actually facilitate the ectosome penetration into the melanoma through using a series of pharmacological membrane inhibitor such as cropamazine for claritrin pathway, nystatin for lipid raft pathway, genistein for caveolate pathway, and whatmanin for macropinocytosis pathway. Now the overall findings indicate that the microwave can actually facilitate the endocytosis of the ectosome via the activations of the lipid raft endocytic pathway, right? So this piece of data is very interesting. So on that note, we actually move on to another set of experiments. So we are wondering whether the solid nanoparticles will work the same way. So in the next experiments, we actually synthesize chitosan 5-fluorouracil conjugate nanoparticles, and similar findings have been obtained. You can see that the skin penetration of the nanoparticles and indicated by the red highlight is promoted by treatment of the skin by microwave at 2450 megahertz for 5+5 minutes. So I wish to highlight to you the duration of exposure is different from ectosome, which is only 2.5 minutes, right? Because of the nature of the dosage form is different. It's solid and it's made from chitosan instead of a lipidic material. And using the FTIR imaging, we also realized that the chitosan nanoparticle actually fluidize the palmitic acid region of the skin, whereas the microwave, it can actually fluidize the ceramide 2 region of the lipid bilayers. So this is the reason why using microwave and chitosan nanoparticle together, they can actually synergistically promote the membrane porosity and permeability and allow more nanocarrier and drugs to go through the skin because they are actually fluidized at a different lipid zone. Now, there's another studies whereby chitosan 5-fluorouracil folate conjugate is prepared. The same finding is attained. This solid nanoparticle can promote skin drug retentions than other control sample, and the nanoparticle can enter into the melanoma cell line via the lipid rough endocytic pathway with the help of the microwave. In the very latest studies of us, we realized that in order to further promote the entry of nanoparticle into the melanoma cells, the chemistry of the chitosan nanoparticle is very important. Now, we have earlier conjugated the chitosan with folate to enable the targeting property. And in this study, I wish to highlight to you the folate content is very important. So generally 20% of folate content with respect to the dry weight of the nanocarrier will promote the nanocarrier penetration into the melanoma. The lower amount of folate or higher amount of folate will actually disfavor, will negate the penetration of the nanoparticles into the melanoma due to the mismatch in the receptor binding and targeting. Now, let me run through the last few slides about diabetes. Now, this is one of the recent venture of our laboratories. In our laboratory, we do look at two pathways to administer insulin. First, by means of oral, but today I'm going to share with you the latest finding by means of transdermal route. Now, commonly, to enable insulin delivery, if you look through the literature, majority of the study, they will use chemical penetration enhancer such as oleic acid, linoleic acid, and linolenic acid that carry a V-shaped structure, enable disturbing of the lipid bilayer of the skin, and hence the skin become more porous and allow the insulins to go through. But in our study, what we realize is that generally the microwave itself can actually promote transdermal insulin permeation, promote transdermal insulin delivery into the bloodstream compared to oleic acid, linoleic acid, and linolenic acid. The fatty acid generally demote instead of promote transdermal insulin delivery. So you can see a high disparity between the microwave and fatty acid in the insulin delivery performance. Now, we have conducted a transepidermal water loss study, DSC, FTIR imaging studies, and the conclusion that we obtained is that microwave can actually improve the skin permeability to a greater extent than fatty acid. And microwave is the residual-free approach, unlike fatty acid, that deposit a hydrophobic shield in the epidermis. So if you use microwave, the skin permeability is promoted. There is no hydrophobic oily lipid in the epidermis that can hinder the insulin transport. So microwave is favorable as the penetration enhancer for macromolecular drugs such as insulin, right? And the other advantage of a microwave, we found out microwave actually translate to a lower variation in plasma insulin and glucose level compared to injection mode. You could see when you use injection mode, the plasma insulin vary greatly, right? Compared to those by means of microwave, right? So by means of microwave, the plasma insulin and plasma glucose level vary to a lesser extent. Now, one possible reason is due to when we inject subcutaneously of insulin, what will happen is that the anatomical barriers for the insulin's diffusions may be highly variable in their quality. As such, the plasma insulin and plasma glucose level is met with a higher level of standard deviation. Right? So this is our very short study about the transdermal insulin delivery. So I hope I give you a new insight about how to identify an innovative approach to deliver small molecule as well as macromolecular drugs through the skin, either for topical treatment or for systemic delivery. So with that, I end my presentation. And again, I wish to thank JIS University. I wish to thank the organizing committee, my university, my students, my partners in research, supplier and manufacturers. I think without their support, I think all this work are not possible to be conducted. So with that, I end my lectures. If you have any questions, feel free to ask me.
Thank you so much, Professor Young. We will have a very short question and answer session.
All right.
So if anybody of the listener and if they're having any questions, please feel free to write in the chat, or you can also unmute yourself and directly ask Professor Young.
Good afternoon, Professor Young.
Hi, good afternoon.
Sir, you said that microwave improves skin permeability. And suppose if a person is suffering from oral cancer and we wish to deliver the medications through the oral route, will microwave still be the preferable route to deliver the medication?
I think for a drug that is highly metabolized in the gastrointestinal tract, and you wish to deliver via oral route, I think there's a possibility of success if you use microwave to first treat the oral cavity, followed by the drugs or followed by the formulation. I think there is a possibility, which I have yet to, how shall I say, experiment.
Thank you so much, sir.
Yeah, welcome.
Please unmute yourself and ask. So we have a question in the chat section. It says that, can microwaves be used to administer anti-cancer drugs like paclitaxel through the skin?
Yes, it's possible. It's possible.
Thank you, sir.
Yeah. You may need to read for me from the chat because my screen doesn't allow me.
Yes, sir.
Yeah, yeah.
Sure, sir. Okay. So as we are not getting any more questions, if you have any other questions, you can write it down in the chat and we will be surely giving it to sir so that he can answer it at any time.
Or you can email to me.
Yes, surely. Yeah. So we have another question which says that as you said that
we have question in YouTube also.
Yes, sir. Yes, sir. So, sir, this question says that, can we see some innovative patches for diabetic studies?
Can we see some?
Innovative patches for diabetes studies.
Innovative?
Patches. Skin patches, sir.
Oh, that means combined with the skin patches.
Yes, sir.
Yes, it's possible. It's possible.
Okay.
Yeah.
Thank you, sir. So another question is there any molecular size limitation?
In terms of the drugs molecule, now you can see from the previous presentation, I have used just a few hundreds Dalton to 6,000 Dalton. So far, the highest molecular weight drugs that I use is 6,000 Dalton, which is very large. And you can see the microwave can actually have the capacity to deliver macromolecular drugs. So for skin drug delivery, skin drug delivery, if you look through the literatures, there's hardly any breakthrough these days, especially for macromolecular drugs. So microwave appears to have the highest potential. Now, we also need to consider other techniques such as microneedle, electroporation, iontophoresis. Now, what are the disadvantages of them and what are the advantages of microwave? If you look at the microneedle, it's workable, but it may be costly and involve a lot of disposable. Environmentally, it's not that friendly. For electroporation and iontophoresis, there's chances of charring the skin. Now, once the skin is charred, it may not be reliable for skin drug transport. So unlike microwave that we use, is hitting the skin volumetrically, the chances of getting charring is very, very minimal.
Thank you, sir.
Yeah.
So we have a question from YouTube. The question goes like, how effective is microwave compared to other routes of drug delivery? There may be chances of mutation.
All right. I guess the microwave is used. Sorry, I think we should phrase the question in this way. I think skin drug delivery is used only when other routes of administration are considered undesirable. Now, for example, if you have injection drugs, you may want to convert into non-injectable route. I think the first route that we should try is oral. So, however, some of the drugs experience a very high level of first-pass metabolism, or you may have some undesirable side effects if you administer through oral route, then we can actually consider skin drug delivery. For skin drug delivery, commercially, we only adopt small molecule, perhaps less than 500 Dalton, and molecule that have a softer in nature so that it can pierce through the skin to a greater extent. But however, in the university, as an academic sector, we do wish to challenge the sizes. So for example, insulin. Now, I have conducted for a number of years on oral insulin. We do have improvement, but the success is still far from the dream commercialization. And hence, we also look into transdermal insulin delivery. Now, this first piece of result is rather promising. So we hope that we can follow up and able to follow up the projects. And hopefully one day we can actually commercialize the technology.
Thank you, sir.
Yeah.
So we are getting a huge number of questions from YouTube, Facebook, as well as Zoom. So what we'll be doing is we'll be accumulating all the questions and emailing them to you. And then we'll be posting it online for everybody to see, because we are running a little short on time. So we'll be doing that. Thank you again, Professor Yong, for this wonderful session, for this really informative session. All the presenters over here are really getting a lot of things from this presentation. Thank you so much.
Thank you.
Thank you, sir.
Thank you.
Moving on, we have our second keynote speaker of the day, Dr. Phagphum Panicha Upakaran. He is an associate professor of the Department of Pharmacognosy and Faculty of Pharmaceutical Sciences, Prince of Songla University, Thailand. His main research interests are development of herbal grain extractions and standardization method, preparation of active constituent rich herbal extracts and plant tissue cultures. His achievements includes 90 publications in ISI, 12 patents and 7 mini patents. He received a lot of prestigious awards, which includes gold medal and special awards from Brussels Innova Expo 2015. Gold medal award from the 45th International Exhibition of Inventions of Geneva 2017, the silver medal award from the 46th International Exhibition of Inventions of Geneva 2018. He started his career as a lecturer of the Faculty of Pharmaceutical Sciences, Prince of Songla University. Thereafter, he became the assistant professor of the institution in 2000. From 1999 to 2017, he remained as the head of the Department of Pharmacognosy and Pharmaceutical Botany, Faculty of Pharmaceutical Sciences, Associate Dean for Research and Graduate Studies, Faculty of Prince of Shangla University from 2015 to 2017. He also served as the Director of Phytomedicine and Pharmaceutical Technology Research Center, Faculty of Pharmaceutical Sciences, Prince of Shangla University. We are fortunate that is here today. It is all day. So first and foremost, I would like to wish him very happy birthday, sir. You may proceed with your session, sir.
Pita,
Sir.
Pita, yeah, we need to stop sharing of Wang sir because it's on the screen.
Yes, sir.
Okay, okay, it's okay.
Yes.
Hello.
Yes, sir, you're audible.
Can you hear me?
Yes, sir.
Okay. So when I can start?
Yes, sir. You may.
Can I start now?
Yes, sir.
Okay. Good afternoon, everybody. Today, I am very pleased to share my research experience on the topic of green extraction for development of nutraceutical for cancer prevention. So today, I would like to share an experience on microwave extraction. First, I would like you to know about the concept of the green extraction. What is the green extraction method? Green extraction method can be described as the method that use non-toxic chemical, especially in the field of herbal extract. We usually use the organic solvent that most of them are really toxic. So in this method, we will not use the toxic organic solvent. Also, other chemicals that may be toxic to human and also toxic or make the environmental toxicity. And the second one is we need the method that less energy consumption, because nowadays we use many high energy instruments, so it will make our earth become warmer and warmer, and it's not good for the earth. So if you would like to save the earth, we should reduce the energy consumption, and also the method have to give the high quality of the extract. So this is the description of the green extraction method, that we need the method that non-toxic, less energy consumption, and also give a high quality of the extract. Nowadays, there are 6 principles for the green extraction method, including the first one, we should use the sustainable resources. It means when we use the plant for extraction, we should use the part of the plant that can be available forever. For example, the fruit. And we may use the alternative resource such as the plant tissue culture, so that can make the researcher can get the raw material forever. And the second concept is related to the increase of the value of the byproduct, or use the byproduct as the recycled material, so we can reduce the waste. And the third concept is about how we can find an alternative solvent that safe for human and for environmental. So we nowadays we try to search for an alternative clean solvent. In my case, because of I'm the pharmacist, so I usually search for the alternative clean solvent from the pharmaceutical excipients that we usually use in the formulation. The fourth concept is all the process we should use the biodegradable chemical or material that can and the fifth concept is related to the method that we use for extraction. The method should be reduce the energy consumption. Then we can reduce the heat or temperature of the earth, and also we can reduce the cost of production. And the sixth concept is also related to the extraction process. Concept is about we should reduce the step of extraction, or we should make the process very simple. In my case, I usually reduce the step of solvent evaporation, because in this step it requires lot of energy for evaporation, and also require the labor, and also we lost the solvent. So if we can skip the step of solvent evaporation, then we can reduce energy consumption and also reduce the cost of production. So this is the overall six principles for clean extraction. And in my experience, and also in my research, our group focused on microwave extraction. For the microwave extraction, we can use household microwave for drying, or for screening, or for optimize the small scale extraction. And after we get the suitable microwave condition, then we can increase the extraction scale to use the larger microwave instrument. In our lab, we have the microwave extractor that have a capacity for extraction for about 40 liters or 40 kilograms. This is the local microwave extractor that made in Thailand, and we may use the high technology microwave extractor, but this kind of microwave is very expensive. For example, for this model, it costs about 1.6 million baht, and the capacity for extraction is only 12 liters, but it can use for distillation of volatile oil. I mean, we can prepare volatile oil using microwave distillation, and it's very useful because it use only about half an hour. We can finish the distillation for 12 liters. For the microwave heating mechanism, many researchers would like to know that how microwave can make a heat. The heat, it comes from the compound that have dipole moment. For example, water that have dipole moment. When it exposed to microwave, the dipole moment compound will have ionic conduction and also dipolar rotation. This phenomenon will make it generate the heat. So inside the plant cell, it had many polar compound or many dipole moment compound that can be generate the heat after export to microwave. This slide, I would like to show you the extraction mechanism. In this picture, this is the plant cell, and inside the plant cell there are some water and also many minerals, phytochemicals that have dipole moment. And when it exposed to microwave, the compound will generate the heat from ionic conduction and dipole moment rotation, dipolar rotation. So when it generates the heat, inside the cell will have a high pressure, and it will make the cell broken and the compound released from the cell more easier. When compared with the conventional heating, when we heat, the heat it comes from outside. From this figure, when we do the extraction using reflux, the heat will come from outside from the heater, and it will be transferred to the container and do the solvent and to the cell. So you will see that the heat, some of heat or energy will be lost. But when compared with microwave heating, when the cell exposed to the microwave, the heat will generated inside the cell. So inside will be have higher temperature when compared to the conventional heating. If you see this slide, when compared with the conventional heating, the heat will come from outside. So in the sample, inside the sample that contain plant cell, the temperature will be lower. When you see the temperature, with the less temperature, it have a high temperature. So you will see that conventional method, the high temperature will be outside and inside will be low temperature. When compared with microwave extraction, you will see that the high temperature it will be inside. So the cell will be damaged more easier than conventional method. When the plant cell has been broken, so it will be released the secondary metabolite. So in conventional method, you heat what you don't want to heat, for example, container. But for microwave extraction, the heat will be generated inside the cell, so it's less energy consumption. In this presentation, I would like to talk about anti-cancer, because nowadays cancer is a global health problem, and it may if the incident is about 8 million people will be got cancer every year, and about 5 million people will be dead by cancer every year. And the most top 5 cancer that cause death, include lung cancer, colorectal cancer, stomach cancer, liver cancer, and breast cancer. This is the top 5 that cause death by cancer. So we try to search for the anti-cancer drug, but nowadays there are many reports. There are many reports on the nutraceutical or functional food from vegetable or fruit extract that we can use it like as the chemo prevention for cancer. But all of the product usually came from free radical scavenger activity because the compound that have property or free radical scavenging activity can reduce the risk of cancer. But most of products still expensive, especially in Thailand. We have to import this product from European country, and the price is very high. So I think about the Thai vegetable that we usually consume every day, and I think that it also have antioxidant activity, and also we try to search more property like anti-cancer activity from the phytochemical in vegetable as well. So our research focus on the anti-cancer compound from vegetable extract. And we use the method for screening of cytotoxicity of the compound. We use Leishmania major, a protozoa that also cause the disease called leishmaniasis. It can cause cutaneous leishmaniasis and also visceral leishmaniasis. So this disease also can cause death as well. And if the compound has cytotoxic to Leishmania major, it's also related to the cytotoxic activity against cancer cell as well. We searched for more than 20 vegetables in Thailand, and we found that 2 vegetable extract gave the good leishmanicidal activity at the concentration of 100 microgram per mil. One is Garcinia cova, and another one is Micromilum minutum. This is the figure of the two vegetable. But in this talk, I will focus on Garcinia cova. Garcinia cova, we usually, in Thailand, we usually use it for cooking the pork belly curry. We use the leaf of Garcinia cova, or in Thai, the plant name in Thai we call chamuan. This the leaf give the sour taste. So when we cook, we usually cook with the pork belly with chamuan leaf. It is the famous food in Thailand, and we also have a product, finished product that can export to other countries. We start to do the research for isolation of the active compound that have cytotoxic to Leishmania. So we use bioassay guided isolation. We use Leishmaniacidal assay for detect the activity of the fraction that we isolate. From this method, when we do the extraction, we get the extract, and then we check for the bioacidal activity, and if it had activity, then we do the further fractionation using several chromatographic techniques. And every chromatographic method, we will check the activity of the fraction, and then we will select only the active fraction to do further isolation. Finally, we get the pure compound. We give the code as GC01. This pure compound has been isolated from the active fraction that have cytotoxic to Leishmania major. Then this compound should have cytotoxic activity to Leishmania major. And after we isolate this compound, then we determine the structure with spectroscopic method. For example, NMR, IR, and mass spec. And finally, we get the structure of this compound. It is the isophenylated benzophenone compound, and this compound is a new compound. This is the first report for this chemical. Then we give the name of this compound from the Thai name of this plant, chamuang. So this compound is namely chamuang. And after that, we determine the cytotoxic activity of this compound against Leishmania major. And we found that it has very good IC50 at about 11 micromolar. So we published the structure of this compound in Food Chemistry journal and also the anti-cancer activity later in Journal of Cancer Research Update. After that, we determine the anti-cancer activity of this compound against top 3 cancer that cause death in Thailand, including colorectal cancer, breast cancer, and lung cancer. And we found that chamuang have very specific activity against colorectal cancer with IC50 of 0.04 micromolar. And it also gives a good anti-cancer activity against breast cancer and lung cancer with a good IC50 values. Interestingly, it had no effect or no cytotoxicity to the normal cell. We use fibroblast cell, normal fibroblast, human gingival fibroblast cell for testing, and at 50 micromolar, did not have any toxic to this normal cell. So it implies that if we get the compound or we use the compound that obtained from vegetable, it will be safe because it is the edible plant, so it do not give any toxic to human cell. And after that, we plan to develop the product from the extract of chamuang. So first, we have to search for the method for quantitative analysis of chamuang. And this is the new compound, so we have to establish our own HPLC condition to determine the contents of chamuang in the extract. And we get the suitable HPLC condition using carbon 18 column and acetonitrile with phosphoric acid at 97 to 3 at the mobile phase. And we already validate the method and publish in the journal. So after we get the method for quantitative analysis of chamuang, then we go to develop the method for extraction. We search for several solvents that suitable for extraction of chamuang from Garcinia cova leaf, and we vary the solvent for extraction with different polarity, and we found that the most suitable for solvent for extraction is hexane. Because hexane is very non-polar and the polarity of hexane is to the polarity of Chamon. So in this experiment, we found that Chamon should be extracted by the nonpolar solvent. But hexane is toxic organic solvent. We cannot use it for development of the herbal product because our FDA or Thai FDA do not allow to use toxic organic solvent for development of herbal product or for extraction of herbal material. And I think most countries also do not allow to use toxic organic solvent for extraction of the plant material for development of herbal preparation. Then we think about the alternative green solvent that can be used for extraction of chamung oil. And we think about the traditional dish, why this vegetable have to cook with the belly, pork belly, or the pork that contain high content of fat. And I think that in the traditional knowledge, they know that the oil from the pork can dissolve or extract the compound from the leaf, and that compound is useful or have the protective property for human health. So I think in this menu, it gives out the idea for extraction of chamung oil, because animal oil also have the property similar to hexane. But if we promote the people to eat this menu every day for chemo prevention, it will be not good for the cardiovascular system. Then we think about the alternative green solvent from vegetable oil. So this is the idea from the traditional menu of traditional food, that we can use the traditional idea for our research. Then I find for the vegetable oil that available in Thailand, can produce in Thailand, including palm oil, lifespan oil, soybean oil, and sunflower oil. And we use it as an alternative solvent for extraction using microwave extraction, and compare with extraction with hexane. And we found that palm oil is the most suitable for extraction, because palm oil contain high content of saturated fatty acids, so it will be more non-polar when compared with the other vegetable oil that contain high content of unsaturated fatty acids. But if we use palm oil when compared with lifespan oil have more benefits than palm oil, because lifespan oil contain a balance of fatty acids, and also contain antioxidant capacity from vitamin E and gamma oryzanol. And what lifespan oil also used as the nutraceutical or dietary supplement for lowering of cholesterol in the blood. And finally, we select lifespan oil as an alternative green solvent, because it can extract chamung oil in high content when compared with hexane, and also it can give useful or benefit to human health. We use the microwave extraction to extract chamomile from Garcinia leaf or chamomile leaf. And this extraction method is very simple. We just mix the plant powder with rice bran oil and put in the microwave oven, and only about half an hour we can get the extract after filtration. Anyway, the microwave extraction method, we have to optimize the condition for extraction. The key factor that we have to optimize is that the electric power and also the time for extraction. After we get the extract, the extract will be oily liquid of rice bran oil that contain chamomile, and we determine the content of chamomile using HPLC, and we found that the extract contains chamomile at 2 milligrams per milliliter. And we use this extract to determine the anti-cancer activity against lung cancer, breast cancer, and colon cancer cells. And we found that the extract also gives the good anti-cancer activity to these cancer cell line IC50 in between 13 to 16 micrograms per mil. And again, it do not have any cytotoxic effect to the human fibroblast cell when we use the concentration of the extract up to 50 micrograms per mil. So this can confirm that this extract is safe for the human normal cell. After that, we study on the mechanism of action of chamomile. We are interested in the tyrosine kinase inhibitory activity, and we test for the tyrosine kinase inhibitory activity of this compound. This compound have the key enzyme tyrosine kinase is tyrosine kinase is the key enzyme for the tumor proliferation. This enzyme the cell need for the step of phosphorylation on the protein, and it will give the signal for the tumor cell growth and proliferation. If this enzyme had been inhibited, you have no signal, and then the cell will have apoptosis. So this enzyme is a key enzyme for the treatment of cancer. And the receptor, epithelial growth factor receptor, or EGFR, is the receptor on the enzyme domain. And this receptor facilitates the tumor growth and spread. If we inhibit this receptor, so the growth of tumor cell or cancer will be inhibited. From the molecular docking, when compared with the modern medicine afatinib that have anti-tyrosinase activity, we found that chamomile have the score for molecular docking or specific to the enzyme higher than afatinib. And after determining the activity in vitro assay, we found that chamomile have IC50 lower than afatinib. It means that it has higher activity for tyrosine kinase inhibitory activity. And we also test the extract. CEO is being chamomile extract with rice bran oil. It also gives the good inhibitory activity against tyrosine kinase at IC50 of 0.1 nanogram per mil. So in this study, we know that Chamumon can cause apoptosis to a cancer cell via inhibition of tyrosine kinase activity. And we also determine the nutrition fact in the extract. The group nutrition fact about on the group of fatty acids. We found that the unsaturated fatty acid component in the extract still have the same level as the authentic lifespan oil. It means that our extraction method did not destroy the fatty acid in the proof of unsaturated fatty acid, because many people have many questions about the vegetable oil when we keep in the microwave and it heated and it's heated, and they are afraid that unsaturated fatty acid will be decomposed by the heat and turn to be the free radical. So in this analysis, we confirm that the unsaturated fatty acid in the vegetable oil do not decompose by the microwave heat. And not only unsaturated fatty acid, but also the antioxidant compound still have in higher amount. So it means that the microwave condition did not affect to the stability of antioxidant compound and polyunsaturated and monounsaturated fatty acid. So this extraction method we already have patents in Thailand, and we make the product prototype into category. The first one is the functional food or nutraceutical. It is in the soft gelatin capsule or the liquid capsule. And also we can make it like cooking oil. Then we can eat like salad oil or salad dressing. This innovation, we got it to the competition in Poland, in international Warsaw invention show, and we got 3 awards from that invention show in 2016. The first award is gold medal. This is the gold medal, and also 2 special awards. 1 special award on stage from Malaysia, and 1 special award on booth from Taiwan, Taipei. So I would like to conclude that we can use a clean microwave extraction for the development of the herbal product, because this method is simple, safe, and safe. Because we use clean solvent, we use microwave, it reduce energy consumption and also reduce the cost of production. So if we would like to develop the herbal product for nutraceutical purpose or from medical purpose, we have to think about the process that's simple and also is safe for human and environmental, and also the cost of production should be low. So this is my experience that I would like to share. Thank you very much for your attention.
Thank you so much, sir. Time we'll be taking very few questions.
Yes, if
So we have a
any
question
question.
on chat box. So the first question for you both is the dry lab will consequence be same for wet lab for tyrosine
Sorry,
kinase
I
inhibitor?
cannot hear you clearly.
Okay, so I'm repeating once again. Molecular docking is a dry lab process. So will the consequence be same for wet lab for tyrosine kinase inhibitor?
Yeah, first we perform molecular docking that it could it get the good score for molecular docking. Then we have to confirm with the assay that it fit to the score for molecular docking or not. From this, you see that Chamungwon give a good score for molecular docking. Then we have to confirm with the experiment to test that it can inhibit kinase activity or not. And we found that the result is agree with the molecular docking experiment.
Thank you, sir.
Yeah.
We are getting a lot of questions on YouTube and Facebook as well. So, sir, what we'll be doing is we'll be mailing you the questions so that you can answer them later on. As we are running short on time, I would like to thank Dr. Phakphum again for this wonderful and innovative session. Thank you so much, sir. It was really informative.
You're welcome. Thank you very much. Thank you.
And happy birthday to you, sir.
Happy birthday, sir. Happy birthday.
Thank you.
Sir, please.
Second session of the day.
Yeah, Sir, yeah, please.
Sure, sir. Sure, sir. So we are at the end. We are at the end of the keynote speaker session. So now we'll be having the break for 45 minutes to 1 hour. Around 1:45 p.m. we'll be rejoining with the same link. And before we end, I would like to give a brief detail about the next session which are upcoming in the second half today. So those are, we are having around 5 plenary sessions of our dignitaries of some of our respected speaker. So for our first session is from 2 to 2:30. Next session is from 2:30 through 3:15. Next session is 3:15 to 3:45, and next is the fourth session is 3:45 to 4:30, and the last session of today, plenary session, would be from 4:30 to 5:15. So these are the sessions we are going to have today. So I hope all of you will join with the same link after 45 minutes, around 1:45 to 1:50. And yeah, you can have lunch by this time. I'll be rejoining again. And thank you so much for all of you for being with us for such a long time and for the nice question and the sessions. So I think we should again join. Majisa.
Yeah. Sir, so we are concluding the session.
Sure, sir. Absolutely. We'll be rejoining at 1:45 or 1:50.
We are all rejoining with the same link at 1:45 to 2 p.m. Okay.
Yes,
Thank you.
absolutely. Thank you, sir.
Thank you all.
Thank you all. Yeah.
Let me stop the recording. Yeah, it stopped. Then let me do one thing.